Hey, what's up everybody? Welcome back to another Cinema 4D tutorial. I know it's been a while, but after about a year, I am finally back. Just like to say thank you to all my supporters, subscribers, everybody that watches my content and it still continues to watch it. I really appreciate that. It's pretty amazing. But anyways, getting back to the video, for any of you guys that have seen my previous tutorials, you'll notice that this one looks a little bit different. That's because I'm working on my Windows machine here, and I normally work on Mac for those of you that don't know. The only reason why I'm using Windows for this particular tutorial is because for what we're about to do, this machine seems to handle it a little bit better than my Mac does. So that's why we're here. Secondly, I'd like to state that I am working with Cinema 4D R16, so a much newer version than I typically work in. I was working in R13 and R14 for a while. So if anything looks a little bit different here, just know that I am in R16. It's possible you have an older version of Cinema that you're running. And third, just make sure you have a pretty decent PC to do this. It's very easy to crash Cinema if you don't have a program that can run these simulations. So let's go ahead and do a rough overview of kind of what we're going to be doing, and then we'll start from scratch. So essentially what we got in our scene over here in the hierarchy, as it's called, is a light, a camera, and really these two things are optional. However, I'd really recommend having a light in your scene. We'll get to that later. An emitter, then we got this TFD tag, emitter tag, and then the turbulence FD container itself, which is where we're going to actually create the explosion. So basically what I've done here is I've just simulated the first 20 frames. So you'll notice once I go beyond 20 frames, you know, the explosion goes away. That's because I haven't simulated past that point. You can stop the simulation at any point, but essentially that's what I have so far. If I go ahead and hit the render preview button, you'll see kind of what we're working with so far. Okay, so you can see what we're working with right now. It doesn't look too fancy at this point in time, but some things I want to make note of is you can already see the smoke starting to appear here. Obviously, the turbulent fire and this grayish color and this darkness in the fire is actually smoke that is mixed in within the fire. So what this does is give you a really nice effect, and you know. We can render this out in such a way that you can drop in backgrounds and everything else, footage, whatever. It'll be immediately composited. You don't have to do any chroma keying or anything like that. So that's really nice. Now, you can't really get around this first part here. I know the first few frames here look pretty bogus, but there's ways to fix that in, say, After Effects and stuff like that. So it's not really a concern. And yeah, so essentially what we have here is an emitter and then the container itself. So I'm going to go ahead and leave this window open, and I'm just going to go ahead and hit File, New. I'm going to leave that window open for reference because it's easy to forget stuff with all the settings and whatnot. So let's go ahead and start here. Let's go ahead and go up to Simulate, and then we'll go to Particles, and we'll grab an emitter. So essentially what this is going to do is drive the actual explosion itself. This is pretty much the foundation for an explosion. So we're going to click on the emitter. I'm going to select the rotation tool. I'm going to click and then hold down Shift simultaneously, and then drag this down like so that it's at 90 degrees. So really what we're trying to do here is get these particles, when we press the play button, to start flowing in an upwards motion, because obviously we want our explosion to explode upwards. Additionally, if you don't use the rotate tool, all you have to do is come down to the P rotation, or the pitch, and adjust that value from 0 to 90 degrees, press apply, and it'll immediately snap your emitter to that orientation. Okay, so we need to go into our emitter at this point. Birth rate editor and birth rate renderer. Essentially, this is saying how many particles are going to be born, if you will, inside the editor, and then this is how many is going to show up in the renderer. So if you want your viewport preview to reflect accurately in your renderer, then you've got to make these two values the same. So I found that 1600, 1500 to 2000 works pretty good for this. And real quick, I'd like to make note that if anything sounds different, it is because I am using a different microphone. But anyways, back to the tutorial. So just go ahead and change the stop emission to 10 frames, for example, and we'll change the lifetime to about 7. So this is how many frames the particles are going to stay alive. The speed is going to affect the speed of the explosion, so I'd recommend going a little bit higher than 150, which is default, to about 160. And then we'll just put some random variation on this. You know, this all comes down to personal preference. You will notice the different effects that you get depending on these settings that you put in here. And for now, I think that's pretty much it under the particle tab. We can go to the emitter tab, change this from pyramid to cone, and then we can bring down, you know, the X and Y size here to something a little bit smaller. Okay, so I think our emitter is set up. So what we need to do at this point is right click on the emitter and go to Turbulence FD, add a Turbulence FD emitter tag, and basically this is going to link the two together. So velocity weight, we can change this to 1. Okay, and particle emission intensity, force channels, let's see what we got here. Okay, the burn here we're going to set to 2, and we're going to set the fuel value to 1. Those are just some values that I found that work very well for the fluid emitter here. Again, I'm trying to kind of recreate what I just showed you guys at the beginning of this video, so I am going to be using similar values. But for now, I think the fluid emitter is all set up. There is one last thing we have to do before we go ahead and drop in our actual container, Turbulence FD container, that is. And that is to modify the radius here. So I'm going to go ahead and go out a few frames to say maybe 3 here. I'm going to change the radius to 5. And like I stated earlier, if you are using an earlier version than Cinema 4D R16, things might be a little bit different, and this is a case in which they are. So pay attention closely here. If you're using a new older version, we're going to make a keyframe, and in order to do that with R16, all we have to do is left click, and you'll notice the circle there changes red. In previous versions, you will have to hold down Control on the keyboard and simultaneously left click to create a keyframe. So for you newer guys out there, that might help you. We're going to go to about frame, I say 11, and we'll drop this back down to 1. You'll notice it changes yellow to indicate a change has been made, and then just left click again to create that keyframe. So essentially from 0 to frame 3, our radius is at 5, and then from 5 to 11, it drops down to 1. So that's pretty much what we got right there. So at this point in time, I think we're ready to go ahead and go into the plugins, go to Turbulence FD, and let's go ahead and drop in a container. Let's go to the container tab and talk about some of these settings. So I'm going to go 250 all across the board here. Okay. So essentially what we have here is this box, and this box indicates what is going to contain our simulation. So let's go ahead and grab our emitter real quick, and let's adjust this, put it right on the bottom of the container, like so. Okay, that should work right there. And we'll kind of place it back here in the corner a little bit. Okay, so we got our emitter in here. Let's go back to the container, and first setting I want to talk about is the voxel size. So that is resolution, essentially. That's pretty much what that is. So the higher this number is, the lower the resolution is going to be, and the shorter your simulation times are going to be. So for simulation purposes, I might turn this value up to, say, 1.8. Okay, so that's going to give us faster simulation times while still allowing us to kind of see what's going on. The next settings I want to talk about is the simulation caches. So when you go to simulate something here, you need to have a cache. So essentially cache is is memory that's placed in on the system, and it's basically pre-calculated. So when you first go to simulate, it's having to, your computer is having to actually think and calculate what's going to happen. But as it does it, it saves like a reference file, or like a reference calculation. So if you simulate, like, say 60 frames, you've already simulated it, you save the cache, then you don't have to re-simulate it to play it back. The computer knows what information it needs to get. So hopefully that made sense. Anyways, I get off on tangents. Essentially, you want to set up a folder somewhere that you're going to remember in case you need to get a hold of the simulation cache. So I would make a new folder, set on your desktop, name it whatever, for example, and basically whenever you go to simulate this, that's where your simulation cache is going to be. When you simulate this at first, it'll pop up here, it'll say like cache 001, indicating the first simulation cache. You can start new ones, and it'll also tell you the size of the simulation cache. So the higher the resolution, the more frames you render, the more complex things that are going on, the higher that value is going to be. So most of the time my simulations are 1 to 1.5 gigs, which isn't really that big, but they can get a lot higher than that really quick. So just be aware. You want to have adequate, enough memory on your machine to do this. Anyways, so right now for simulation purposes, I'm going to keep the voxel size at 1.8. Alright, so let's go ahead and go into the actual simulation itself. So the first thing I'm going to do is go into the timing tab here, and I'm going to adjust the time scale to 80%. And essentially what this is going to do is make our explosion play back a little bit slower. So that's pretty self-explanatory, and that's pretty much all we want to do there. You can change that to any value you want. The smaller the value, the slower the playback's going to be. The higher the value, of course, the faster. So we'll go into velocity, and let's check those settings. I think everything's good there. Wind, we can add some wind. So this is pretty much if you want to have your explosion look like it's, winds affecting it or driving it. These are your different orientations, like X, Y, and Z and whatnot. So if you change this value, this is going to indicate, like, for example, which direction the wind's going to be coming from. And then the wind speed, of course, is self-explanatory. So if you change this value, the higher, the more dramatic that effect's going to be. So I'll say put it at like 10, 15, 20, whatever you really want there. Vorticity. This setting here is going to make the simulation look pretty good. You just don't want to go overkill on it, because if this value gets too high, then it's going to look kind of bogus. But I found that like 20 works pretty good. But when we do that, we want to change the intensity channel from none to density, and that'll help the overall look a lot. Turbulence, once again, personal preference here. Changes this from 0 to say 15. This is going to make the actual explosion look a little bit more turbulent, a little bit more complex and dynamic. So the rest of our settings look pretty good here. Let's drop down to temperature and the cooling. The buoyancy is going to be affect like the way the smoke looks. So I typically change this value up a little bit higher to say like 70, 60, 70, and the cooling is how fast the fire itself is going to cool. And 2%, which is default, seems to be a pretty good value for there. Density is a big one, so we want to go ahead and make density active, and this is going to be the dissipation rate. So once again, 2% is pretty common there. That's used quite often, or at least I do. I don't really mess with that value too much. Just make sure that's checked on. And then we'll drop down to fuel. Go ahead and make this active as well. Okay, and we'll go ahead and change the fuel diffusion from 0 centimeters to 0.3. And we'll leave the burn rate at 1. Okay, and then we'll go ahead and mess with the expansion temperature emission and density emission values. So the expansion is pretty self-explanatory here. This is this value is gonna control how quickly and how dramatically the fire itself expands upon initiation. So when you start the simulation, you don't really need to go too high on this. Like say 0.2. The higher this value is, the more dramatic the effect is going to be. Once again, temperature emission, change that to 3. Density, go to like well, let's try something different. Let's go to 13 and we'll make this 6. You just kind of got to play around with these values to see what you like. As with a lot of things with cinema, that's kind of just how it works. And lastly, we'll go down to burn. We'll make that active, and we'll change the decay from 0.1 to 0. Or my bad, we'll go ahead and make that to 0.02. So now that we have that set up, it looks like our actual simulation itself is good to go. So we're going to go into the Viewport Preview and go through those settings. We're going to change the channel from temperature to density, and shader, we'll leave that at none, and I think that's good. Okay, now we're going to go to rendering. Let's check these settings out real quick. Okay, we're going to leave general alone. We're going to go to smoke shader. We're going to change the mapping from none to density here. Okay, and once we do that, we're going to come down to color and opacity. This is going to be the thickness of our smoke, so we can adjust that value. Say 17, 15 by default, and then the smoke color, obviously that's pretty obvious. So we can double click on that little knot there and adjust the smoke color, make it a lighter gray, maybe a little bit darker than that. Okay. Once again, all personal preference. Illumination here, this is just kind of how the fire, the light, the luminance from the fire is going to interact with the smoke. We got various settings here. This will speed up your render times, voxelize fast, accurate. It's going to do exactly what it says it is. You're going to get more accurate results, but it will take longer to simulate. But for now, I'm just going to leave it as is, not messing around with it. We're going to come down to the fire shader here and change the channel from temperature to burn. And let's see, let's come down here. The color, we're going to leave the opacity at 2. We'll leave the low and high temps right where it was. I'm going to bring up the white point up just a bit to 1.5. And the damping to 5.5. This affects the color essentially of the final render of the fire. So white point 1.5. You'll notice when we update these values, you'll actually see the color gradient adjust in real time as well. Let's check our subgrid detail settings. Okay, everything looks good there. Alright, I think all these settings are good to go. I think so. Let's go ahead and do a quick simulation here, and we'll see what happens. So let me go ahead and start this. Okay, so once again, you can see that we adjusted our voxel size, so the resolution is not great at all, but it does render very quickly, or simulate very quickly. Any point in time, we can stop that. If you guys don't have this in your pane here, the actual simulation options, you can go back up to plugins, go to Turbulence FD, and you can click on simulation window. Now I've already got it docked down here, but it might come up in a little dialog box. You just grab this, click and drag it, and you can drop it wherever you want it into Cinema. So yeah. Let's go ahead and go back here. This is exactly what I was talking about earlier. Notice the simulation carries on long enough to escape our container. So when it starts exiting this container, it gets cut off and it's no longer being simulated. So you need to watch that and pay attention to it, because that can really mess some things up for you. But since this is just a tutorial, I'm not going to worry about it too much. I'll go ahead and press Control R on the keyboard and give this a quick render and see what's going on. Now, first thing you're going to notice is it looks pretty crap, in all honesty. It's very low resolution. We don't have any lighting going on here. You can start to sense the effect that's being given here. So it doesn't look that bad, but we will need to increase the voxel size and whatnot. Long story short is, if you're satisfied with what you have at this point with the higher res, that's when you can go on and make this voxel size smaller to increase the overall resolution of the simulation. I'm going to go ahead and drop in a regular light, an omnidirectional light, so this is going to emit light in all directions. I'm going to drag it up and off to the corner. Doesn't really matter, we're just going to place it somewhere like that. And I'm going to go down to shadow in the settings and change it to shadow map soft. And that's pretty much all I'm going to do for that. This is just going to put some light inertia to make our explosion look a little bit better. So if we pick a random frame here, we can kind of see what's going on. So you can see the fire effects here in the smoke and how it's kind of interacting with each other. It looks pretty natural and dynamic. So I like what I have so far right here. So what I would do is, like I said, go back into the container here, adjust the voxel size down. I would never go down below 0.5 or anything, depending on how powerful your machine is. This is very RAM and CPU intensive, and if you put that value too high for your machine, then your software Cinema will crash on you. So you don't really want that, right? So I'm going to put it down to 0.5. I found if I go any lower than that, my system tends to have a really difficult time handling that. So let's go ahead and give this a simulation. I will go ahead and pause the video because this will take a minute. So I'm going to go ahead and do that right now. Alright guys, welcome back. As you can see, that took 9 minutes to simulate. But let's go ahead and skip ahead our frames here. Let's find a good frame to render real quick, and we will kind of see what this is shaping out to look like. Okay guys, so that one frame took, as you can see down here in the bottom left hand corner, 1 minute and 12 seconds. But look at the final outcome here with the voxel size. The resolution increased. We're getting all that detail and the smoke and the fire and whatnot. So additionally, you could take this into After Effects and dial down the settings, color correction, all of that, which is really cool. But for just raw render right out of Cinema, using very minimal settings here, we're getting a very nice outcome. Not mean to press that. So what we need to do, once we've got our final product and we're satisfied with it, we can come into our render settings here and adjust the width and height of our animation. So I would change this to HD. So I'm going to make that 1280 by 720. Additionally, you can go 1920 by 1080 or higher resolutions, of course. And go ahead, if you're doing an animation, make sure you set it to all frames or manual and designate the amount of frames of the simulation. We'll come down to save, and let's see, come down to save. We can save this out as PNG files, for example, with alpha channels turned on. Make it a 16-bit channel, and then we can just name the files, go to desktop there, hit save, and if we wanted to, we could increase the geometry or the anti-aliasing from geometry to best, which would make the animation look better, but that's going to increase the render times quite a bit. So I'm just going to leave that at geometry for now, and I think all of our render settings are good to go. So I'm only going to render out this current frame here, and we can drop in a camera if we wanted to. Go here, zero out any rotation on the camera, and turn that camera on so that we're looking through the lens, and just get the camera adjusted properly, and then play back our simulation. My computer isn't quite fast enough to play back the simulation while recording, but if I do grab it on the timeline, you can kind of see the simulation there that's happening, and kind of how the smoke and fire is evolving. So pretty neat effect, guys. Hopefully you guys learned a lot with this, and If you guys got any questions, comments, or concerns, you know what to do. Leave me a comment down in the description. If you have any requests for tutorials, anything you want to learn how to do, please don't hesitate to let me know. I'm always open to any ideas, so just everybody remember that, please. Once again, thank you for subscribing to my channel. I also launched a new website called projectmotiongraphics.com. Go check it out. I'll be updating it pretty soon. It's got some photography stuff on there, motion design stuff, some of my more popular tutorials and things of that nature, and About Me page. So if you guys want to, go ahead and feel free to check that out. The link will be down in the description. And I think that'll do it for this tutorial, guys. Thank you so much for watching, and I will see you guys again soon. Peace out.